Hey, good morning all. Welcome to math class again. I hope you're as excited to make progress as I am. Okay, today we are going to look at probability. And probability is something that you'll see every day. Every time you buy a lotto ticket with your gas, you are counting on a probability that you will win something. What's my chance of winning? Every time we look at data for our basketball teams in high school, we're looking at the probability of what their placement is in the chances of them going to state or going to district or going to regionals. So we have a lot of stuff in life where we are constantly dealing with probability. Every casino out there is doing probability. And the probability that they're doing is always in favor of the casino. It's never in favor of the player. And I know you sit there and go, well, so-and-so won a lot of money at the casino. But how many people lost so that one could win? And that one who wins is always going to win less than what the casino is bringing in the number of things that people lost. And so it's always in favor of the casino. But we talk about probability, even the weather report every morning. What's it say? What is the probability of rain today, or snow, or ice, or sunshine? Every day we talk about probability. What is the probability that you will get in your car, you will drive to work and arrive safe and sound? So you see, we deal with probability every day. So let's look at this subject of probability in a more precise way instead of just in general as we live it. So we're going to start with probability. So what is probability? Probability is the random chance that the favorable outcome will win. So, as you can see, we have a lot of vocabulary in the words that we just used with probability that we need to go ahead and define. So, as we look at probability, what kind of words do we have here? We have a word such as the word trial. What is a trial in relationship to probability? It is an experiment or any process that produces a random result. The next word we're going to look at is the word outcome or outcomes. Outcome is what? An outcome is an individual result of one element in a trial. For example, my trial could be, what is the chance of having 3 boys and 1 girl out of 4 children. Okay, that would be my trial. Now, there's a lot of different ways that that could happen. And one outcome of that would be a boy born first, a boy born second, a girl born third, and a boy born fourth. That would be one outcome of this trial. Okay? So now let's look at the word sample space. A sample space is all the possible outcomes of a trial. And we'll show you what that is in a bit. Okay? And then an event. Event is a group or a subset of the outcomes in the sample space. A group or subset of all the outcomes in a sample space. As you see, these words just keep showing up over and over again in these definitions. So let's look at what we can do here. Let's look first at 2 coins. I'm going to flip 2 coins. Now, as we flip 2 coins, what is our possible sample space of this particular flip? Flipping 2 coins is my trial. Okay? My outcome is going to be my first flip of the 2 coins. I flip the first coin, and then I flip the second coin. My first coin can come up true, or it could come up false. So one outcome of flipping my first coin, say it's true. Now I flip my second coin, it also can come up true, or it can come up false. Or if my first one came up false, my second one could come up true or come up false. So now those are, the outcome would be an individual result of one element of the trial. So what is that outcome? Well, my outcomes of this would be true, true. That would be one possible outcome. True and false here would be my second outcome. My third outcome would be if my first one is false and my second one is true, and then false and false. So an event, but a trial in this particular thing is what I'm going to do. I'm going to flip 2 coins. The result is random. I flip it, which way is it going to land? It's random. So that's my event. My outcomes are true, 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 false, false, true, or false, false. So each one of these is an outcome of that trial that I did. My sample space is all of these outcomes. So if I'm going to list what is in my sample space, which you have to do in problem 1 and 2 of your assignment, you will have to actually list them. And then I always like to tell how many are in that sample space. N often stands for the number in the sample space. So N has 4 in it. There are 4 possible outcomes within that sample space. Now, an event is what I decide I'm going to look at. And we often write that as the probability of an event. Well, what event do I want? Well, let's say my event is going to be having all falses or all, no. I did true and false instead of heads and tails. Well, that was pretty smart. Let me go back and change this to heads and tails. I can't believe I did that. See, I'm thinking a truth table. Heads, tails, heads, tails, heads, tails. So we have heads, 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 tails, tails, heads, and tails, tails. Okay? So my probability of my event is that I'm going to end up with two tails. Okay? So the event I'm looking for is two tails. That's the event. Okay? So now that you understand what those mean, you know what they are. A trial is what is the experiment that you're going to run, or what is the theoretical experiment that you're going to run, and we'll go into that. An outcome is an individual result. In other words, if I'm flipping two coins, an individual result would be both coins land with the heads. Okay, my sample space is all the possible outcomes of the trial, and the event is what am I asking for out of that possible sample space. In this case, my event was two tails. Okay? So now let's look at some definitions of the kinds of probability we have. We have two kinds of probability. We have classical. That's the name our book uses. More often, I usually see this under the name theoretical probability. And the other kind of probability we have is empirical. What is the difference between these two? Classical probability. Classical probability is, in theory, what is the results. In other words, what I drew up over here with my two coins, this one is theoretical probability. I have the possibility of a heads and a tails, and a heads and a tails on the second coin, and this gives me my sample space of the probability that I drew up from that particular trial. Okay? So, this is theoretical, and it's theoretical because I did not take two coins and flip them, see what happened, write it down, flip them, see what happened, and write it down. In other words, in theory, this is what is going to happen. Okay? In theory, what is the result? It is not actually performed. Performed as an experiment. And empirical probability is actually do the experiment. And because you do the experiment, the results of the experiment are used for the probability. Okay? For example, I'm going to flip a coin. Theoretically, or in classical probability, I have a 1 out of 2 chances of having, or a 50% chance, or I could say 0.5 chance, of having a heads show up. Why? Because there is 1 head and there are 2 in the sample space. So we'll go more into that. But I have a chance of 1 out of 2. In other words, a 50% chance of having a heads show up. That's by theory, because there's 2 sides to the coin. But now what happens? What if I flip that coin 10 times and got heads, heads, tails, heads, tails, heads, heads, 2, 4, 6, 7, tails, tails, heads. Let's see, 2, 4, 6, 8, 10. I have 10 of them. So we know that there's 10 in my sample space because I flipped the coin 10 times. How many of those were heads? 2, 4, 5, 6. So by my experiment now, my probability is going to be 0.6 or a 60% chance. So according to empirical probability, I have a 60% chance of having a head, but according to theoretical probability, I have a 50% chance of getting a heads. And what you will find if you do a lot of probability is that the larger the sample set, the closer the experimental probability will be to the theoretical probability, because theoretical probability is based on thousands in the sample set, or just the fact you have 2 options, so therefore one of those options gives you a 50% chance, as in flipping a coin. Okay, so that's the difference between classical and empirical probability. Okay, so let's look at how do we construct a sample set. Okay? So a sample set is made up of the possibilities that are given to you. So my trial, we're going to look at a trial. My trial is flip a coin, then roll a dice. So what are my possible outcomes in this particular trial? Well, flip a coin. I can have a coin flip and get a heads, or I can have a coin flip and get a tails. And I'm going to set this up in what's called a tree diagram because it's easy. I can roll a dice, and I have 6 possible things can happen with my dice. Because there's 6 sides to the dice, I can go roll a 1, a 2, a 3, a 4, a 5, and a 6. Or I can roll a tail, and again, I have 6 possible outcomes on my dice. So, in building this sample space, and in problem 1 and 2 of your homework, this is exactly the kind of thing you're going to do. And you're going to then list every possibility. So I can have a heads and a 1, a heads and a 2, a heads and a 3, a heads and a 4, heads and a 5, and heads and a 6. Or I can have a tails with a 1, a tails with a 2, tails with a 3, tails with a 4, tails with a 5, and tails with a 6. That builds my sample space. So what is my sample space for the trial that I gave you? All of this is the sample space. So I have 2, 4, 6, that means I have 12 are in my sample space. Okay, so that's the first thing you're going to look at. My sample space for rolling a dice is those 6 possibilities. You would simply list them. What is my sample space of having 2 children? What's my sample space for that? Well, my first child can either be a boy or a girl. My second child can either be a boy or a girl, just like in the others. So now my sample space of that is going to be boy, 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 girl, girl, boy, and girl, girl. That's my sample space. So that's the first thing you have to learn, is how to figure out your sample space. All right? So this is very necessary. There are 4 in the sample space. And you must know the sample space, or the number in the sample space, to even begin to do the probability. Now we're going to look at the probability. We're going to look at an event within that probability. And remember, event is a subset. Okay? So, what if I wanted to have an event that said, in the children, 1 boy and 1 girl. I want a family with 1 boy, 1 girl. So, how many events in this sample space have a boy and a girl, or a girl and a boy? I have 2 of them that have 1 boy, 1 girl. So, this event would have 2 in it. And so that's what you have to look at. What is the event? And when we start talking probability, we talk about the probability of the event. In other words, we refer to event as an E when we're talking about probability. So my probability of an event will be on, the formula will be on the next video. But let's talk a little bit more about probability in general. Okay? In classical probability and also in empirical probability, let's just say in probability in general, what happens on my numbers in probability? Well, probability either can go only between 0 and 1 inclusive. In other words, 0 is my smallest probability, 1 is my greatest probability. If I change to percent, then my percentage in probability is 0% through 100%. In our book, most of the time, they are going to be asking you to put probability in this realm here. In other words, your numbers are going to be decimals. And often the book will ask you to carry that decimal to the 6th place value. Okay, so what is my 6th place value? It's 0.12345 tenths, hundreds, thousands, 10,000s, 100,000s, 1 millionth. So this becomes the 1 millionth place value. Okay, so there's a lot of stuff going on there. So that's why you need to pay attention to your place value, because it's very precise. Okay? If I have a probability of an event is equal to 1 over 2. That means this is equal to a 0.5 probability. And if it terminates, which is what this does, it stops at 0.5, do not carry it out to the millionth place value, just write 0.5. Or if they asked for a percentage, it would be a 50% probability. Okay? If I have a probability of an event is equal to 1 out of 6, this means 1 out of 6 chances, or 1 out of 6 in a sample space, which is equal to and that one doesn't terminate, and I didn't write that down, so let's see what that is. 1 divided by 6 is 0.16 with a repeating, which means 0.166666. If I'm going to go out 6 places, so I'm going to go out to the next one. And this one is 5 or greater, so it's going to force this 6 to go up. So if I'm rounding it correctly, this is going to be 1.166667. And you can put your 0 in front. All of you go into nursing need to get in the habit of writing the 0 in front of the decimal. It's a requirement in nursing. Okay, so this is what we've got in probability. Or this could be changed to percentage, move your decimal 2 places, and I have 16.6667%. Okay? So that is a way to write probability. Another thing you need to know, if I have 0 over a number like 6, okay, 0 out of 6, this is equal to 0. And 0 is the smallest number you can have in probability, and this means it will never happen. Okay? Or I could have 6 out of 6, which equals 1, which is the largest number in probability, and this means it is absolutely certain to happen. And some of your probability is going to ask for that. Okay, as you look at your assignment now, numbers 1 and 2 will require you to do a listing of the sample set, and 5 through 11 in the assignment will ask you to decide, is it classical probability or is it empirical probability? Remember, classical or theoretical is just there's this many possibilities and I'm going to choose one of them, so therefore it's theoretical. Empirical probability is I actually did the experiment. So as you decide whether it's theoretical or classical versus empirical, use that knowledge to decide that. We're going to stop this video and I'll start a new video for the second half for this assignment.